they had parts from the other chapters as well. So we didn't realize, but yeah. So now we are ready to move on to chapter 4, because in chapter 4 there are certain things in 2 dimensions um, that need actually more care than we did in chapter 1, right? So we will only be focusing on parts that are not possible to pay attention to in 1 dimension, right, or in one direction. So again, you will see diagrams, and yeah, much of this is pretty standard. Yeah, the coordinate system, you have it. You will have an origin. Yeah, thank you. And any point. So the difference from chapter 1 now is that the path of motion can now be any curve. Yeah? And that curve is very interesting. That curve will be placed in a 2 dimensional plane, right? So that is one reason. But remember, you can even have a motion in a 2 dimensional plane, but the motion itself will be in just a straight line. Yeah? So if I replace this, I can still use 2 axis for some reason because I find it convenient, but my convenience will not determine whether it's a 2 dimensional motion or a 1 dimensional motion. What if the particle moves just in a straight line? So I'm using x and y only for my convenience, but the actual motion is in 1 dimension. But here, the motion itself is in 2 dimensions, right? So here, it's not just about convenience. Actually, the motion is in 2 dimensions. So it means that you need to now be more careful with these points and position vectors, and yeah, x and y, things like that. And just remember that whenever we are using, by the way, I have uploaded 2 documents, both from chapter 1 and chapter 4, and where I pay particular attention to these labels. So when you use a label x or y or t, for that matter, that will not be a single value, but it will be the whole coordinate, right? So what that means is that even if you write something like this, let's say I write x equals 5, and let's say this is in meters or some centimeters or whatever. So this doesn't mean that 5 is a value of x, because x is a coordinate. What this means is a state of motion where the position is 5, right? So the actual value, so the meaning of this equal sign is different. So let's say I have frames, yeah, frame 1, frame 2, frame 3, and let's say this happens in the second frame, in the so then instead of x, it will be more sensible to write x 2 for the second frame. And when I write this thing, this will have another meaning. This means that both these two are actually the same things. So this is just a name for 5. Yeah? So you must not confuse this statement with this statement. This is a question. You are actually asking where x is 5, because x is not one value. So you are actually pinpointing it here, on that axis, where do you have 5. But here, it's an equation you see in math. Yeah. So this is one symbol, this is another symbol, and they both mean the same thing because you just have given it a name. ये बात समझ आ गई? ठीक है? So this is the unknown, and this is a coordinate. Yeah? So let's get back to position vector. We know everything. And if you want to compute now displacement between any 2 points along the motion or along the path, you know how to calculate the vector, yeah, delta r. And so you see, even this notation was discussed in that chapter. There's nothing new here. The only thing that is now different is the definition of the average velocity. So now, now it has to be in the form of a vector. Yeah, so this is a displacement vector, you know it. This delta means change. And this will be the x component of that velocity, and this will be the y component of that velocity. But because delta can only be between 2 points, the only name you can give to this side is the average velocity. Why is it average? Because of the delta, right? Because delta cannot give you velocity at one point. That's what makes it an average. So how do you go from the average to the actual? Actual means the velocity at a point, right? So, and you know it from calculus that if you take the limit, yeah, you bring that second point closer and closer. So in the limit you will have just one point, and then you can now define your velocity vector at a single point, let's say 1. And what will be the definition? The limit of that ratio. So you can safely say that the instantaneous, this is what you call it, yeah? The instantaneous velocity is the limit of what? Give me a name from the previous slide of the average velocity. Instantaneous velocity is the limit of the average velocity, and how to take that limit? Bring these 2 points so that they actually combine into a single point. Okay? This is what you do. So when you make that limit, you know this thing becomes is replaced with d. So d only reminds you that you have taken a limit, and you call it derivative, right? Derivative is from math, you already know that. And the notation now changes. I no longer need to write average here, yeah, and I can even attach a label to it. So I can now speak of v1, v2, but this v1 and this v2 will have different meaning from chapter 1. In chapter 1, when we were writing v1, v2, v3, what we had in mind, that was only notation. It was still an average velocity. Here, this will be the instantaneous velocity. So the meaning of the symbol changes when you come to this chapter. And when the subscript is x or y, because we know x is not a number, x is a coordinate, so you cannot say vx means velocity at one point, because x is not a point. It only means the x component of velocity. समझ आ गई बात? So अब ये वो मैं कहना चाह रहा था कि normally अगर आप ये कह रहे हैं कि if it is vx, so you cannot replace this x with 2, for example, to make it 2. So this will not mean x equals 2 in that sense. ये बात समझ आ रही है? क्योंकि here you are thinking of x as an unknown. X is not an unknown. X is a coordinate, yeah, which can freely move along that axis. Okay, so I think that was a reminder from calculus, and this is the notation we'll be using for the x component, for the y component. Yeah. Achha, whenever we say x and y, that automatically is the position. Yeah. What will be an alternative notation for x? Just like vx. What x? The x component of what will give me x itself? Just like, yeah, this is the position vector, right? The position vector is the only vector which doesn't need to be written explicitly. Yeah, the x component, because that's how we define x. Yeah? X is a coordinate, so whether you write rx or whether you write x itself, they both will have the same meaning, right? Okay, so now the next question is, now our focus is at a single point, right? At that, and one more thing, in the first chapter we were using frames because the purpose of using the word frame was to visualize, so that we have that camera in mind. Now we will be solving problems, and it will make more sense to use the word point. So you can think of it as a point along the path. And the advantage of using a point, and you will see it in those examples which I uploaded, is that you can choose the points according to your convenience. The time interval between 2 points may not be required to be the same, because it's just your convenience. But when you were calling it frames, remember from chapter 1, the time interval had to be the same. So I can choose 1 point here and 1 point here and 1 point here. I don't care about the time interval, because that's the reason for labeling these points with 1, 2, 3 is to solve the problem, yeah? And not to argue about anything like that. ये बात समझ आ गई? तो वो जो rocket वाला example था ना, going up and coming down, if you look at the diagram, you had many frames, many dots, but he has used only 2 points, 0 and 1. Actually 3 points, 0, 1, 2. Yeah, 0, 1, 2, and you had many frames there. Yeah, but so we are using 0, 1 and 2 not for the frame numbers, but for convenient points to solve the problem. You also very. So let's say this is our point. So one description of the vector, and this vector will be our velocity vector, right? Will be to specify the x component and the y component, the rectangular coordinates. This is what you typically call. But another description will be to just specify the length and the angle, right? The length and the angle. So the length will be called, what will be the name for that length of the velocity vector? Speed, yeah? It will be the speed at that point. So you can even have instantaneous speed. Speed at a point. That is just the magnitude of the velocity vector. And what will be your name for this quantity? Let's say this is 10 degrees. So this 10 degrees will be the angle. To be more precise, you should call it the angle measure, right? Because the angle is the whole geometrical object, and it's just like, yeah, this is an object of mass, yeah, let's say 10 gram. Yeah, so 10 gram is not the object, 10 gram is a property of the object. Yeah, so when you say angle in math or in geometry, you mean this whole object. And what is the whole object? This ray, and all the space in between. This is what you mean by the angle. But when you measure it, you get a number, and that number is what you mean by the angle measure. Now, people are not very careful every time, so they say angle, but what they have in mind is the angle measure. But you must be clear. So depending on how I ask a question, if I allow you to be informal, it's fine. But if my question requires you to be accurate, then you have to distinguish between the angle measure and, it's just like line segment and the length of a line segment. Yeah, this is a line segment, but the length is a length. Length is not equal to the line segment. Yeah? बात समझ आ गई? Okay, so angle measure, but we use another word in physics as well, and that is the direction. So the speed and direction. So what will be your mathematical object representing direction? Is theta enough? Can we say theta is the direction? So remember, I am using the conceptual word and the formal word. Here I say, so yeah, so like here I had speed, and here I had the length of the, no, not velocity, the magnitude. Yeah, the magnitude of the velocity vector was my speed, and here I need something for the direction. So can I say that theta is enough? No. Why? Because direction is a complete description. Theta requires you to have this reference, and you are not mentioning that. What if this was theta? How do we know whether theta was this thing or this thing? Or maybe this axis can be changed. I can choose another coordinate system. I can choose, for example, this coordinate system. Let's say this is my x and this is my y. Then, so theta alone cannot be used to completely characterize direction. There is one thing mathematically which completely characterizes a direction, and that is the unit vector. Now you know why we need the unit vector. Yeah? We don't need it for fun. That's the only way to talk about direction. regardless of what coordinate axis you use, whether this is your theta or that is your theta, unit vector will be a vector of length 1. Why? Because the length is not what you need. Yeah? So 1, why not 0, for example? Because you will be multiplying this with the magnitude. And if you keep it 0, then everything will be 0. So you see, sometimes we use 0 and sometimes we use 0 when we are adding. We use 1 when we are. So 1 and multiplication means that that thing is not important for you. You are only interested in the direction. So that's why unit vector has, okay, unit vector will also have no units. Why? Because it is only meant for the direction. Units कहाँ पे आएंगे? Speed में या magnitude में. समझ आ गई बात? So if I'm, let's say this is north, right? So if this is north, this will be, tell me, east, yeah? If this is north, then you cannot tell whether this is east or west, then hopeless situation. Yeah? So east to north. So if I now, how can I, let's say this theta is 10 degrees, yeah? So how should I say? Direction will be, I'm specifying direction, 10 degrees. I have to write something to make it, so V will be equal to 10 degrees north of, this is how you say it in English, north of east, which means that you start from east and you move towards north. I don't care about the value, yeah, whatever the value is. This can even be here, right? Let's say this is 120 degrees. Yeah. So what will I say? I can still say 120 degrees north of east, because it is only telling you where you start and how you move. It doesn't say where you stop. It can even come here, yeah? So let's do it like this. Let's say it is this 10 degrees and this will be, no, let me tell you, this is 10 degrees and this will be 350 degrees. So I can either say 350 degrees north of east, it is still north of east, because I start from east and I move towards north. I don't care where I stop, because that is not part of the language. Or if you find this inconvenient because you are pampered and you only need to understand simple language, then you will have to say this 10 degrees. This is what the schools do to you, by the way. They think you will be confused, and I want you to be confused, because only being confused will change your approach to problem solving. 10 degrees? Yeah, south of east. They're the same thing. South of east. Now let's change this language to x and y, because we don't like north, east. Yeah. So how will I change this? 350 degrees above x-axis. Now we are into the formal word. Yeah? And 10 degrees below. And now there is a question for you. You have to tell me now. अब पता चल जाएगा आपको, समझ आइए वैसी जो है ना वो, हाँ we understand it. Yeah. Will it be below x-axis or will it be above x-axis? नहीं वो लिखा मैं तो क्या, ये x-axis है ना मेरा, और क्या मसला है? नहीं मैं इसको एक्सेस कह रहा हूँ ना, ये मैंने देखो ये एक्स एक्सेस है और ये बिलो है. सो कैन आई से -10 डिग्रीज बिलो, तो मैं बिलो भी कह रहा हूँ माइनस भी कह रहा हूँ. कौन लोग हो तुसी? या आप बिलो कहेंगे या माइनस कहेंगे, दोनों नहीं कहेंगे. तो माइनस आप तब यूज करेंगे व्हेन यू वांट टू इंसिस्ट अबव, तो माइनस अबव को चेंज कर लेगा. सो -10 degrees. So basically this is the same as 350 degrees north of east is the same as -10 degrees again north of east. Because I want the negative sign to just do the job for me. I don't want to repeat the thing. समझ आ गई? It's like a loss of 10 rupees. Yeah, it is a gain of negative 10 rupees. So I cannot say a loss of negative 10 rupees. A loss of negative 10 is actually a gain of 10. So you need to fix that thing in your brains. Okay? So now you know clearly how you specify. What is another way of this specifying the unit vector? You just write the x and y component of the unit vector. तो वो क्या होगा? You just write I, j, and let's say you are using this theta, yeah? So it will be cosine theta plus, because you know cosine squared theta plus sine squared theta is 1, so it is guaranteed to be a unit vector, yeah? Okay, cosine theta, sine theta. So you now know three ways of mentioning or reporting the direction. You cannot say theta because theta is not the direction. Theta is just one property of the direction, which alone means nothing. So that matters for you, because when I ask for the direction, you need to give me the complete answer. You cannot say, oh, theta is equal to 10 degrees. That is not acceptable. So you either say it in the language of north of east, east of north, south of east, yeah. Then above, below, and you can even use. There is no requirement of using x. You can do it like this. Let's say this is x, this is y, and let's say I want to call this my theta. So this will be west of north, west of north, or
left of y-axis?
no, I mean above is something you I mean it's not cool anymore, yeah. So you should say ahead of y, because you always assume this counterclockwise, yeah? Ahead. So even ahead can be used here as well. Ahead of x-axis, ahead of y-axis, behind x-axis, behind y-axis. Yeah. And you should take note of these things, okay? क्योंकि ये इनमें से हर चीज आपको शायद बुक में ना मिले, तो because you are in the class, you should be taking notes. Okay, one more thing. Typically, you use this formula for the length of a vector, whether it's a speed or distance or whatever magnitude. Yeah, you know, you're very used to this thing, and you also use this formula. Yeah, y-axis, and remember this is not always y over x. This is actually the side opposite to theta, right? So if this is my theta, for example, if this is my theta, then it will not be y over vx. It will be, yeah, because then this is the opposite. Okay. But there is one more thing. ये तो हो गया कि vx कभी आएगा कभी y आएगा, ठीक है वो तो. But the other issue with this formula is that, let's say I get an answer from this, right? और अब मैं एक काम करता हूँ, मैं इसमें माइनस लगाता हूँ इसके साथ और इसके साथ भी. The answer will not change. Yeah, but the actual thing has changed, because I have moved from one quadrant to another quadrant. If they were both positive, I was in the first quadrant, and now I'm in the third quadrant. If it was positive and it was negative, I was in the fourth quadrant, and now I will be in the second quadrant. This function doesn't know what is going on, and you are pressing buttons, yeah, and you think that you got the right answer. No, you cannot rely on your calculator. ये खोपड़ी अल्लाह ने दिया, आपने इसको पहले इस्तेमाल करना है, कैलकुलेटर बाद में आता है. समझ आ गई बात? So first you need to figure out कि which quadrant, is it here, is it here, is it here, is it here, और फिर उसके बाद आपकी लैंग्वेज भी ठीक होगी ना. So you figure out the directions of the components before doing any calculation, right, of the angle, Of course, you will need to know these components, right? And then you have to decide, okay, it's in this quadrant, so you choose the best axis for your reference so that your answer is always between 0 degree and 90 degrees. That's what we call the acute angle, right? So these will always be positive for you because you have chosen it carefully. So if I know the answer is here, then this thing and this thing will always be positive, and I will not need to care about. So I'll always go with the magnitude, but I have to choose that coordinate carefully. अब समझ आ गई बात? So यहाँ पे कभी भी आप जो है ना वो actual values नहीं लगाएंगे, तो आप यहाँ पे क्या करेंगे? Absolute values, but of course then this theta has to be placed so that it is always acute. क्योंकि acute में वो चक खत्म हो जाती है ना कि वो इधर है उधर है उधर है. So you are not relying on the calculator. ये बात समझ आ गई? And how do you measure acceleration graphically? Of course, you can use head to tail rule. That is something you already know. ठीक है? ये head to tail rule आपको पता है. So ये मैं दोबारा repeat नहीं कर रहा. और इसमें आपको पता है कि because it's delta, so one of the vectors has to be reversed, yeah, minus vf minus vi. So vf को आप as it is लगाएंगे और vi को आप क्या करेंगे? Flip करेंगे, and then you will still be using the head to tail rule. That is something you know better than me. And you can actually try to solve this, yeah, graphically. That is something you can do. Let's say we read this statement, right? This statement: a ball rolls down a long hill through the valley and back up the other side. Draw a complete motion diagram of the ball. So I'll only discuss things that are actually, before doing this, we need to write down the equation for the acceleration, because maybe I skipped some of the slides, right? So just like the instantaneous velocity is simply the derivative, right, of position, and whenever I write this thing, you have that limit in mind. Yeah? That's something you do. In the same way, the instantaneous acceleration will be the limit of the average acceleration, and that will automatically bring you to that same, but this time the derivative will be with respect to the velocity. Now this change in velocity can be in two forms, or it could be a combination. The change could be simply because the magnitude is changing and the direction is not changing. That is one way in which you can get acceleration. What is the other way? The magnitude is not changing and only the direction is changing. And in general, it could be any combination of these two. So if you have the first case, then you can only be in one direction, yeah. But if you have the second case, the motion has to be curved, and not just any other curve, but one curve, the circle. The circle. Why? If it is anything other than the circle, it means that it's a combination of the two. Speed भी change increase हो रहा है. Why would the radius change? The radius changes only because the magnitude is also changing. ये बात समझ आ गई? So अब आप इस एंगल से इसको देखें. In this part of the motion, it is going straight. So only the magnitude is changing. That's why the acceleration vector and the velocity vectors are in the same line. So यहाँ पे जब आप compute करेंगे, so only the magnitude will be changing. Vector unit vector दोनों का same होगा. और यहाँ पे क्या होगा? इधर मैं बाद में आता हूँ. यहाँ पे क्या है? The velocity vector is upward. The acceleration vector is downward because its speed is slowing down. Still in one dimension, but here you cannot say that the magnitude is changing. Can you say that? The magnitude is, yes, the magnitude is changing just like this, but what else is changing?
The direction of acceleration.
Yeah, so because these are two different directions, you have that negative sign, right? And here, you have to use this head to tail rule, right? Okay. So because it's changing the direction as well, when you apply this rule, the change in velocity will be in a different direction and it will appear as if it's towards the center. वो जो सेंट्रीपिटल एक्सेलरेशन होता है वो क्यों आता है? वो ऐसा नहीं है कि वो उधर जा रहा है, वो इट इज स्टिल गोइंग इन दिस, बट बिकॉज ऑफ दिस वेक्टर एडिशन द डेल्टा वी पॉइंट्स समवेयर एल्स, एंड दैट्स एग्जैक्टली व्हाट हैपेंस इन अ सर्कल. रिमेंबर, सर्कल में एक ये हो गया फिर ये हो गया, तो इन दोनों का जो रिजल्टेंट है वो क्या कहाँ होगा? वो सेंटर की तरफ होगा. तो सेंटर की तरफ वेक्टर का मतलब ये नहीं है कि वो जा रहा है सेंटर की तरफ, इट्स ओनली द चेंज. So it's a consequence of using this head to tail rule. Yeah, this is now a very important thing. We typically use X and Y. Yes. So we define our X and Y in such a way that it is in line with our day-to-day experiences. So typically I would always like to call this X my X and this my Y, but this is only our day-to-day experience. You can use any direction. So if, for example, if something is going along the surface, it makes more sense to use this as your x-axis. Why would you bother to call this as your x-axis and this as your y-axis? If you use this as your x-axis, then you don't even need a y-axis. You just need one axis. Okay? So, but here you can't do that, yeah, because the speed and the direction are both changing. So you may have one axis along the motion, wherever the motion is, and one axis normal to the motion. So actually you have a coordinate system which is not fixed, but it changes with the think about this. Let's say here I use this as my x-axis and this is my y-axis. What will be the case here? This is my x-axis, this is my, and this x and y, they are changing with time. And here, right? So instead of calling it x and y, because many people get confused with this, there's nothing wrong, by the way, with calling it x and y, because you are allowing x and y to change with time. Another way of getting around this confusion is to call it a parallel and a normal. Yeah. So this is for the normal, this is for the parallel. So this will be the tangential direction. So it always follows the tangent to the curve, and this will be the normal. So this is now your centripetal acceleration, and this is your tangential acceleration. You have now two components. So which now means this is something very interesting. I can now write my acceleration vector in two ways. I can either write it, if I use x and y in the traditional sense, x and y, I can either say ax, a, y, I, j. This is one way of specifying the acceleration vector by its components along x and y are traditional. Or I can say a parallel, a normal, and I will now have to come up with vectors. I cannot use I and j because I and j are now fixed for the traditional way. So I can use t and n. Guess it. Tangential unit vector and normal unit vector. You will always need a unit vector. Yeah? Because without the unit vector, you can't have a complete description of the direction. ये बात समझ आ गई? And what is the third way? That is an obvious way, which will use just one unit vector. Magnitude of A multiplied by the unit vector of A. You must have this in mind all the time. This is something you can do all the time because just one vector, so it will have a unit vector. अच्छा, इसके फिर इसमें फिर I J और ये आएंगे जरूर, लेकिन this is a legitimate description of the vector. And you know, now you see that because you are multiplying, so that's why unit vector का magnitude क्या होता है? 1 होता है, so that it doesn't destroy the magnitude. अगर ये 1 के अलावा कोई वैल्यू होती तो इसने उस एक्चुअल मैग्नीट्यूड को क्या करना था? चेंज करना था. So that would have been a disaster. So now you know कि यूनिट वेक्टर को हम मैग्नीट्यूड 1 इसलिए देते हैं कि that's the only way to make sense of this multiplication. बात समझ आ गई? एक्सेलरेशन मैथमेटिकली में तो आपको सारी बात है, ये इसने वही बता दिया कि you can have a general curve in mind, right? And anywhere you can imagine two axes, the parallel and perpendicular. So this is your vector along the tangent, and this is your vector normal to the tangent. इन दोनों का यूनिट वो क्या है? रिजल्टेंट. तो इसका एक मैग्नीट्यूड होगा, इसका डायरेक्शन होगा. मैं लास्ट में मैंने ये यूज किया हुआ है. So this last line is to be in line with this magnitude, direction. Second line is in line with these two, and the third line will be if I have a component of acceleration along this x-axis and along this y-axis. अच्छा, एक चीज यहां पे नोट करनी है. Typically, whenever we specify components, we have to use sometimes negative, sometimes positive. Yeah, if it is along the x-axis, it's positive. If it's against, it is negative. अब मुझे बताया कि अगर ये मेरा tangential direction है, ये because it is moving. Remember, the velocity vectors is right and upward. Yeah. So this acceleration is against the tangential direction. So why don't I have a negative sign there? This is a question for you now. This v is along the tangent, yeah? तो ये तो ठीक हो गया. अब ये against है, so why don't I have a negative sign? Because the arrow is doing the job for me. समझ आ गई? अगेन वही मसला है ना कि वो जो -10 डिग्री और +10 डिग्री. अगर मैं ये कहूं, ठीक है, क्योंकि ये इसके ऊपर एरो लगा हुआ है ना, और इधर भी एरो लगा हुआ है. इफ आई नाउ राइट the component of the acceleration algebraically, and if this is my tangential direction, उसके साथ फिर नेगेटिव साइन आएगा. ठीक है, लेकिन यहाँ चूंकि वेक्टर मैंने दिया हुआ है, वेक्टर में वो साइन नहीं आएगा. ठीक है, ये इसकी मिसाल ऐसी है कि लेट्स से यू आर एनालाइजिंग मोशन ऑफ ए पार्टिकल अप एंड डाउन, राइट? सो किसी भी पॉइंट पे you draw a vector, the acceleration vector, due to gravity, and you call it the g vector. And let's say this is your y-axis. Y-axis upward. तो देखो ना, y-axis upward है, ये vector downward है, but you're not writing any minus sign. Why? Because this vector is doing the job. But what if I want to write g y? What will be that? Let's say the value is 9.8. So gy is equal to, now I have to say minus 9.8 meter. Why? Because gy is component of g along the y. Y तो उधर है, तो अब माइनस साइन आएगा. ठीक है, अब ना एरो है ना डायग्राम है जो आपको हेल्प करे. सो नाउ माइनस साइन इज द ओनली वे टू सॉल्व द प्रॉब्लम. तो बात समझ आ गई? And can I write g here, simple g? Yes, because when a symbol has no arrow and no x or y, it's the magnitude, and magnitude is always positive. So small g alone will always be the magnitude. ये तो मैं पहले ही कर चुका हूं, ठीक है. And if you have constant acceleration, by the way, you have studied constant acceleration in schools and colleges, uh, you can actually have these equations of motion. The good thing about these two dimensions is that every component will have its own equation, and the mathematical form will be the same. So if you somehow manage to write the equation of motion, and you are very familiar with these equations, right? For the x-axis, the same set of equations will apply to the y-axis. And even if it was a three-dimensional motion, you will have the same set of equations for the z-axis. Only the values will change, right? So initial, I is for the initial, f is for the final. Yeah. So the new position, this is how you read. The new position is computed from the old position, and let's say the computation is only along one axis. Yeah. So along the x-axis, you have to do this in order to make to understand the equations. Along the x-axis, the new position, not the displacement, the new position. Yeah. What is the displacement? Xf minus xi. That will be the displacement. X alone is the position. So the new position is computed from the old position by adding if I don't expand this, what should come here? It will be the change in position, which means the displacement. And displacement has to come from velocity and time interval, right? Velocity and time interval. So the best thing you can do is, because the acceleration is constant, so you can use the average velocity, right? You can use the average velocity, the initial velocity, and whenever the acceleration is constant, the average velocity will be vi plus vf divided by 2. That is something you can always do, but only when the acceleration is constant. So this will be v average times delta t, v average times, and v average will be vi plus vf divided by 2. When you do that, you get this expression. So this lengthy calculation is a consequence of that rule. Yeah, v average times delta t, v average is vi plus vf, and vf is then vi plus at, a delta t. When you plug it, you get this thing. So इसका मतलब ये है कि आप इस equation को replace कर सकते हैं by a simple equation where you just rewrite this as v average times, and you write another equation, v average is vi plus vf divided by 2. These things you can solve yourself because it's simple head to tail rule. Okay? How do you reason? So now we are into projectile motion, right? In projectile motion, you have studied it in detail. You need to understand one thing very clearly, that just like we model an object as a particle, right? That is not the only part of the model. Any assumption you make is part of the model. So saying that this is a particle is just one part. The next is that in the chapter 1, you were modeling motion as in the straight line, and sometimes even in one direction. So in projectile motion, you also need assumptions. So the word projectile is actually a model. So it's a motion along a specific type of path. And there are some characteristics, some assumptions you have to make. The first assumption is that, of course, the particle, it's a particle. The second assumption, you ignore air resistance, because if you include air resistance, you can't have a projectile. So these equations don't apply. Yeah. So that is part of the model. So when you say model, you will have to say particle, yeah, ignoring resistance, things like that. And the other thing is that because of this, when you so you can write the equations for x-axis alone, y-axis alone, velocity, acceleration, position, all those things. Now, one thing which is very clear about a projectile is that because the two equations can be written independently, if you only focus on the x-axis, there is no acceleration. So you also are assuming the flat earth model. Yeah. So from the start till the end, although you know the earth is not flat, but the model projectile, because it's a model, you must assume a flat Earth model. If you allow this to be a curved surface, then there is no projectile. So you should now know which details will actually destroy your model: air resistance and curved surface. So we have to ignore both of these if you want to use the equations of projectile motion. ठीक है. अब इसमें नुक्ता ये है कि if you stick to the x-axis because it's flat, so it means that there is no gravity along the horizontal, right? So which equation will you use? Which of the two equations will you use? No, what change do you need to make in these equations so that you can use them for the x-axis, for the motion along the x-axis of the projectile? Acceleration zero हो जाएगी ना, ये acceleration x-axis में तो नहीं है. So all the equations will simplify by setting a to zero. ये a zero, वो नहीं, वो vertical है. और vertical में ay will be replaced with minus g, because you want y to be upward. So ay has to be replaced with minus g and ax has to be replaced with. So this is part of the model, remember. Ax is 0, ay is g, is part of the projectile model. Sorry, negative g. ठीक है. Now this has a consequence. वो तो आसान है ना कि वही स्पीड जो इनिशियली है, वो जो इनिशियल वेलोसिटी का जो x कंपोनेंट है, that will remain the same till the end. So there is no question, no confusion. But between these 2 points vertically, from this point to the maximum, the velocity is decreasing when you are moving up, and it is increasing you are moving down. The speed, by the way, क्योंकि velocity में तो direction भी आ जाता है. So now one thing is you need to keep in mind that the gravity which was responsible for slowing it down while it was going upward, the same gravity is responsible for speeding it up. So it means that you can now split this problem into two problems. This from the start till the maximum height, and from the maximum height till the end, and they must have the same time interval. Because how long it takes depends on gravity. Gravity is the only thing that changes the velocity. So you cannot tell me, oh, these time intervals will be different. So the reason these two time intervals are the same is because of projectile model. So you can simplify your calculation by solving the problem midway and just multiplying the time interval by 2. ये बात समझ आ गई? ये आप ज़हन में रखिए. So if you want to reason about the projectile, you are ignoring all the resistance, क्योंकि actually फिर ये होगा ना, actually ये होगा अगर आप if you include the air resistance and all the other details. So you typically have a launch angle, right, and an initial velocity, and this path is parabola. You know that from math, from previous math. And you typically write this. Okay, now one more thing, like just a while ago I told you that when you are specifying the angle theta, right, you need to be very clear, about the reference. Is it with respect to x, with respect to y, with respect to minus x, with respect to minus y? But in projectile motion we typically have a standard, so we always use this as our x-axis and always use this as our y-axis, but only for the projectile. So it means that when you use the symbol theta in the context of a projectile, right, somebody has to remind me in the last I would say 15 minutes. Okay, the quiz is 10 minutes. I need 5 minutes to distribute the quiz. So ये बात क्या चल रही थी? Yeah, theta. So even if it is not mentioned, it will always be above the x-axis. So which means that in these contexts you have an alternative mathematical representation of a direction. So इससे पहले हम क्या कह रहे थे कि when I want to specify the direction, I have to say either x and y component components or some angle, and then I have to say north of east or south of west. But here I can use a simple notation, or in any problem where it is understood, whether it is agreed by the convention, that will always use. Yeah, just like when you are now you are studying calculus, and in calculus there will be a point of trigonometry, and there somehow you will always assume that the angle theta is measured above the x-axis. When you do that, and there is this assumption, because you want to make this assumption every time, so there is a name for such an angle. ये बात ज़हन में रहे. Normally we just use the word angle, right? But when you use this assumption, mathematicians want to use a name so that you always remember the convention. They call it the standard angle. Yeah, you will see it in calculus. It's not just the angle, but the. So actually, the precise name is angle in standard. I think standard. No, there is another thing. Angle in the standard, and there is something which I forgot. Okay, so that means that it is always above the x-axis, right? So, if that is the case, or if this is the case, like we have it in the projectile, then what you can do is that, let's say you have a velocity or any other vector, and you want the direction, which is the unit vector. So you can simply say the magnitude, comma, the angle. Now, the only, I mean, you need to distinguish it from the horizontal, yeah, from the rectangular. So, how to distinguish this from Vx? I remember, आप मुझे ये ना कहे कि हाँ यहाँ Vx है और यहाँ V है. When you are actually putting the values, you can easily distinguish this from this if you are using units. क्यों? क्योंकि इसमें दोनों में मीटर पर सेकंड होगा, इसमें इधर मीटर पर सेकंड होगा और इधर में यूनिट नहीं होगा. But what if I don't want to use units at all? Then some people use a semicolon. So comma here and semicolon. So this semicolon will remind you that you are using the polar coordinates. But remember, polar coordinates will always assume the angle theta or phi or whatever is symbol to be above, so that you don't have to mention it explicitly. समझ आ गई बात? So this is the model, yeah, projectile motion. This is part of the model, projectile motion. And here are some points, yeah, and you can actually calculate all of these. Okay, so let's say we, I mean, this is something which you can do yourself, yeah. So, so let's start reading it from here, okay. A stunt man drives a car off a 10-meter high cliff, 10-meter high cliff, at a speed of 20.0 meters per second. ठीक है. So ये कौन सी motion है? Horizontal. ठीक है. और at a height. How far does the car land from the base of the cliff? अच्छा, what does off a cliff means? Okay, he has reached that end and he is now actually leaving. Yeah. So because he's crazy for whatever reason. So how far does the car land from the base of the cliff? Pay attention to the language. From the base. So he's only interested in the horizontal distance. He's not interested in the vertical, what happens vertically. तो अब इसमें क्या है? इसमें वो gravity, you don't even need to pay attention to gravity. This problem. So इसमें velocity क्या होगी throughout? नहीं, velocity will not change, yeah. क्योंकि you are solving the problem only along the x-axis. Yeah, but I know, but to solve that problem, this speed will not change. Why? Because when you are leaving, let's say this is the cliff, yeah, and it is leaving here. So initially the velocity vector will be pointing to the left. So later on it will change direction. But you are not concerned with this motion anyway. You're only concerned with.
X-axis.
So this problem can relieve you of any consideration along the y-axis. So it means that जो मर्जी हो जाए इसका जो x component है वो वही रहेगा जो स्टार्ट में था, which is 20 मीटर पर सेकेंड. ये थोड़ी देर पहले मैंने ये बता दी कि बेसिकली x is equal to 0. x is equal to 0 is part of the model which you call projectile. ये बात समझ आ गई? So अब हमने क्या करना है, हमने सिर्फ इस horizontal जो velocity है which doesn't change with time, वो क्या है, इसको मैंने किससे मल्टीप्लाई करना है, टाइम से, right? And it will give me the distance. So all I need to know to do is to calculate this time. समझ आ गई?
So we have to figure out when it lands.
Yeah, so
The vertical velocity.
या सो अब आप डेल्टा टी के लिए सोचे कि हो सकता है वो जो वर्टिकल मोशन है वहां, अब चूंकि डेल्टा टी आपका मसला है, तो डेल्टा टी के लिए आप क्या करेंगे कि इसका जो वर्टिकल कंपोनेंट है वो यहां पे क्या है, 0 है, और यहां पे क्या होगा, मैक्सिमम होगा. ठीक है. सो बिटवीन दीज टू यू कैन फाइंड सम इक्वेशन, और वो इक्वेशन में आपको एक्सेलरेशन उसमें कांस्टेंट है, g इज द कांस्टेंट, राइट. सो अब आप देखिए कि अभी थोड़ी देर पहले मैंने आपको क्या कहा था कि द एवरेज वेलोसिटी और द यू कैन से एक्सेलरेशन इक्वल्स acceleration along the y-axis, right, equals delta t, और यहां पे क्या होगा,
9.8.
no, acceleration is the rate of change of velocity. But do you need velocity? That's the thing.
We don't know the velocity.
Yeah, so it means that we need to use the equation which uses actually the height, right? So वो जो equation उसने दिया हुआ है, think about this equation, right? You need to pay attention to the equations, right? किधर है? प्रोजेक्टाइल का इक्वेशन किधर था? इस इक्वेशन नहीं दिया हुआ ना? But we can do this, yeah. Although this is not for the projectile, but we can now set. So in this set of equations, x will be 0. Like using this is not useful. Why? Because we don't know delta t, right? But if we come here, the yi, what is yi?
Vertical initial vertical velocity.
अगर आप ग्राउंड को 0 करते हैं ना, if क्योंकि now you need that x and y, right? So if this is your origin, then that 10, yeah, is your y. Initial value is actually 10, yeah, and with some units, meter. The cliff was 10 meter high, remember? ठीक है. And yf will be 0, right? Yf will be 0, and you know the acceleration, which is g, right? So ay is equal to minus g. Can you now give me an equation from your school physics which tells me the time? यही इक्वेशन है, देखो ना, इसमें आपको yf भी पता है, yi भी पता है, yf 0 है, yf क्या है, yf 10, सॉरी yf 0 है, yi 10 है. a की वैल्यू आपको पता है, ये 0 है क्योंकि इनिशियल वर्टिकल कंपोनेंट इज 0. ay क्या है, माइनस g है. So you will use, I'm not going to solve the problem, I'm just telling you the strategy. This is the only equation which will help you. From this you will calculate delta t, and that delta t will be used in the other equation. Now you come, so from here you straight away jump here, sorry, here, yeah. This ax is 0, this delta t comes from there, and you know these two, yeah. This is 0 and this is the initial speed. सो इसमें कोई घबराने वाली बात नहीं, आपने सिर्फ ये देखे, बिकॉज यू विल बी गिवन द चीट शीट, यू विल बी गिवन ऑल द इक्वेशंस, यू जस्ट हैव टू थिंक कि कौन सा इक्वेशन पहले यूज करना है, कौन सा बाद में यूज करना है, ठीक है. सो वो जो वी एफ, वी हैव एक्चुअली eliminated the need of calculating v f, although we know it will be non-zero, but we don't need it, ठीक है. इसलिए इसको सॉल्व किया हुआ है, बाद में पढ़ ले, ठीक है. ये जो आपको, अच्छा, बाय द वे आई डोंट लाइक दिस फार्मूलाज, बिकॉज अगर चीट शीट में फार्मूला है फिर तो ठीक है, लेकिन ये जो फार्मूला आपको नजर आ रहा है, इट इज एक्चुअली अ कॉन्सिक्वेंस ऑफ व्हाट आई जस्ट टोल्ड यू, and that is something you can always do. You should use a strategy which always works. This requires you to memorize some formula. What if I don't give this formula in the cheat sheet? मेरी मर्जी है, मैं ये वाला फार्मूला देता हूं, नहीं देता, because I want you to be able to use the formulas I have given to you. So then you cannot, you do have to look at how the author solves these equations, but you must be able to solve it by going the basic principle. Basic principles क्या है कि इक्वेशंस आपको दिए गए हैं प्रोजेक्टाइल मोशन के या टू डायमेंशनल मोशन के, एंड यू नीड टू बी एबल टू डिसाइड व्हिच इक्वेशन टू यूज फर्स्ट, व्हिच इक्वेशन टू यूज आफ्टर दैट, ठीक है. बेसिकली इसने किया हुआ है, अगर आप देखें ना, यही सॉल्व करके इसने इक्वेशन लिखा हुआ है. सो मैं ये नहीं कह रहा कि ये इसने रट्टा मारा हुआ है, बट मेनी ऑफ यू विल स्किप दिस रीजनिंग एंड दे विल जस्ट सी, ओह ये मैजिक फार्मूला मुझे मिल गया. तो ये मैजिक फार्मूला आपको काम नहीं आएगा कि all I have to do is to change the language of this question slightly and then this formula will not work. Then what can you do? ठीक है. So you always need to be able to solve the question in the most basic way. So understand the reasoning, right? The next thing I want to do is let's get to the book, क्योंकि जो no, I think we can, this problem which I want to solve is also in the slides. By the way, you must also be able to solve these kinds of questions. So in a while I'll be getting to a numerical question, okay, that is more important, but before that let's read this and see how will you answer.
No.
Does the arrow hit the coconut?
No.
Why?
Because the coconut will get dropped a bit by the time the arrow reaches the coconut.
So you are actually assuming that the what is he using? He is using a bullet,
No, it's an arrow.
an arrow. Sorry, an arrow. That the arrow will go straight, right? So the gravity which makes the coconut fall is the same gravity which will make the arrow fall.
So it will hit it later. It has to
No, because the same gravity is acting on both, they both will drop.
the arrows have to go up first.
No, initial direction तो उसकी ठीक है ना. If there was no gravity, let me tell you, if there was no gravity, he is pointing straight, he will hit it. Yeah. Now the coconut falls because of gravity, right? That same gravity is acting on the arrow. So जो ग्रेविटी इस कोकोनट को यहाँ ला सकती है, वो इस यहाँ पे उसकी जान निकल जाएगी एरो में. They will both come down to the same point. Bang. So it's about the G.
But it does depend on how much force he is applying.
No, that is not. Look at the equation. Equation में क्या है? आप complicate कर रहे हैं ना. Equation में तो force है ही नहीं. Equation में क्या है? VI, VF, G, XI, XF, H, YI, YF. So the determining factor in this problem is gravity.
लेकिन सिर्फ फिर हम ये कह सकते हैं कि कोकोनट ना गिरता तो एरो हिट पहले ही मिस
लेकिन वो गिर गया है ना. ना गिरता की बात है, जो स्टेटमेंट आप वो पढ़ लेना, वो गिर गया है.
इसका एक मारेगी गलती से लग से लग
नहीं, देखो ना, वो एरो कर सकता है ना, उसने वो किया हुआ है, वो ठीक किया है, ठीक है. लेकिन मेरा क्वेश्चन ये है कि जो नीचे आ रहे हैं दोनों, आप ये क्यों नहीं सोच रहे कि वो दोनों जिस वजह से आ रहे हैं वजह सेम है ना. ये तो नहीं है कि ग्रेविटी उसके लिए अलग है और इसके लिए अलग है. ये वही है जो कौन था, गैलीलियो था, इसने स्मॉल, क्योंकि एयर रेजिस्टेंस देखो ना, यू आर यूजिंग द प्रोजेक्टाइल मॉडल, एयर रेजिस्टेंस को आप इग्नोर कर रहे हैं. So when you are ignoring the air resistance, heavy, light, they will both fall. It will take the same amount of time to drop. तो जितने टाइम में ये कोकोनट यहां तक आ गया है, उतने टाइम में एरो भी नीचे आया होगा. आप इसमें वो डिटेल शामिल कर रहे हैं जो क्वेश्चन में दिया ही नहीं है. So if your answer is different from this, it means that you don't understand the meaning of the model, the word model. Model यहाँ पे क्या है? No air resistance, and both are modeled as particles. आप एरो की लेंथ को देखें, ये तो लंबा है और कोकोनट तो शॉर्ट है. These are details which are not part of this model. Projectile में क्या मॉडल है? Particle. Arrow is a particle. Coconut is a particle. गेम मुक गई सारी. Air resistance इसके लिए भी नहीं, उसके भी नहीं. Gravity इसके लिए. So there is nothing in the model which will change the situation. Yes.
जो horizontal velocity wouldn't that change?
Yeah, but horizontal velocity हमारा concern नहीं है ना.
Sir, isn't it a projectile? उसकी तो दोनों types की velocity होती है. Horizontal and vertical.
या तो उसकी horizontal velocity zero है ना.
हाँ, horizontal उसकी initial zero है, लेकिन he does apply an acceleration.
Yeah.
To the arrow.
वो acceleration सिर्फ downward है.
Is there no?
No. Gravity is always vertical.
No, I'm asking he shot the arrow.
Yeah.
So there is a horizontal velocity and a horizontal acceleration.
Yes.
So that would depend if it does depend on that if it hits the coconut.
Yeah, but that will be only if the coconut was moving right left. Coconut is not moving right left. Coconut अपनी जगह पे खड़ा है. Let me tell you, if there was no gravity, the coconut would be there and he would have hit it. Is this possible? Yeah.
Yes.
Yeah. So it means that the time it takes, yeah. So it is in the same line. So that coconut, it will be missing it only if the coconut was moving right left. The coconut is only coming vertically.
But the arrow is moving right left.
Yeah, the arrow is moving right and down, not right left. Right and down.
It is moving both.
Yeah, so if it is going this way, if it can hit it, it will now moving this way and it will hit
What if
it.
it's going faster? What if it's going slower?
What?
It's still not hit it.
Yeah, but then if this is your reasoning, then it should not be able to hit it even if the coconut doesn't fall. By your reasoning, yeah, but it will hit it. When if I
in this specific question, it's projectile.
You are adding details which is not in the question.
Projectile motion.
Projectile motion में सिर्फ ये change हो रहा है ना, वो तो change नहीं हो रहा.
जो नहीं होता change projectile motion में.
The coconut is not a projectile.
Arrow की बात कर.
हाँ, तो एरो का सिर्फ ये कंपोनेंट, ये वही कंपोनेंट है. देखो ना, अगर वो स्ट्रेट होता उसने स्ट्रेट हिट करना था. अगर वो एंगल है तो उसने तो सही एंगल चूज किया हुआ है ना. जो आपके जहन में क्वेश्चन आ रहा है, दैट इज आंसर्ड बाय द थीटा. The shooter has chosen the angle theta in such a way that it will hit it. So if you have any questions with this, you should ask this question right from the beginning. ये वही क्वेश्चन है ना कि वो जीसस क्राइस्ट का है ना कि वो बगैर मदर के कैसे पैदा हो गया. वो आदम अलैहिस्सलाम पे उनको क्वेश्चन नहीं है जो माँ और बाप के बगैर पैदा हुआ है. जीसस पे उनको मसला है. तो आपको इससे प्रॉब्लम नहीं है तो इससे क्यों है? समझ आ गई ना? There is nothing going on. So this is what happens to you. You are adding details which is not there. Don't add your own details to the problem. इस प्रॉब्लम में आप सिर्फ फोकस करें कि क्या चेंज हो रहा है. चेंज क्या हो रहा है? वर्टिकल नहीं, फिगर तो बना हुआ है. फिगर बना हुआ है, देखे ना. ये उसका क्या पाथ होगा? स्ट्रेट पाथ. अगर वो ना गिरता तो आप मुझे ये बताएं, इसके बाप बनाते थे. डू यू बिलीव दैट इट विल हिट इट? यस, बिकॉज ही इज हंग्री एंड ही नोज व्हाट ही इज डूइंग. नहीं, मैं कह रहा हूं अगर ये ना गिरता, नहीं, ये ठीक है, मैं बात नहीं कर रहा. मैं कहता हूं कोकोनट ना गिरता तो क्या करता ये? कैन यू शूट इट बाय द वे?
Sir, he didn't know the angle.
हाँ,
Shooter को नहीं पता गिरेगा या नहीं गिरेगा.
नहीं, शूटर एक्सपीरियंस्ड है. शूटर ने उसको स्ट्रेट नहीं किया होगा. उसने
नहीं, लेकिन उसे प्रेडिक्ट कैसे किया गिरेगा या नहीं गिरेगा?
वो डिटेल यहाँ पे गिवन नहीं है ना. हाँ,
एक क्वेश्चन में वापस दी हुई है.
ठीक है. नहीं मैं ये कह रहा हूँ कि जब वो अगर उसको पता है कि इसने नहीं गिरना ना, तो बेसिकली नॉर्मली आपके पास इतना एक्सपीरियंस होता है कि यू पॉइंट या सो दैट इट विल ऑलवेज हिट.
So,
ठीक है.
he was pointing at the initial
Yes.
position of the coconut.
Yes, yes.
So shouldn't it hit the initial position of the coconut instead of the falling coconut?
Yeah, so it actually it means that if यहाँ पे बेसिकली एक और मॉडल भी है from normally. If you actually apply the trajectory here, then it can miss it here as well because it's not falling. Yeah? It's not falling, right? So by that I agree. It will only hit it if he is experienced enough to choose a different angle, so that even if it drops a little bit, it still hits the. So that is again that is the detail which is not given here. Question is much simpler than that. समझ आ गई? क्वेश्चन ये है कि वो ड्रॉप कर गया है. इसका मतलब कि द फैक्ट दैट इट ड्रॉप्स हियर मींस दैट इवन दिस इनिशियल डायरेक्शन इज गुड इनफ, बिकॉज नाउ दे बोथ विल ड्रॉप बाय यूजिंग द सेम लॉ ऑफ ग्रेविटी. यहां पे असल बात यह है जो हॉरिजॉन्टल, इवन उस प्रॉब्लम में भी जो आप कह रहे हैं ना, उस प्रॉब्लम में भी हॉरिजॉन्टल वाज नॉट प्लेइंग अ रोल. ठीक है, only the vertical, because it would still miss it because of the gravity. If it is to miss that, even if the coconut is not dropping, the missing will be because of the gravity, not because of the horizontal detail. So you are adding something which is not in the question. ये असल बात ये है इसमें. ठीक है, ये इसने किया हुआ है ना, देखिए वो नीचे आ रहा है, तो ये भी नीचे आ रहा है. So basically यहाँ पे हुआ ये है कि it's a blessing in disguise. Blessing in disguise है. वो अगर उधर होता तो शायद ही वरना उसकी मिस कर लेना. ठीक है, ओके. वी नीड टू एक्चुअली ओके, व्हाट विल बी योर. असल में यहाँ पे ना कुछ क्वेश्चन यहाँ पे है ही नहीं सर. हाँ, ये आई वांट यू टू आंसर दिस क्वेश्चन. रीड द क्वेश्चन फर्स्ट. And you have to read every bit of the question. अब यहां पे ना, यहां पे आप यू आर मिसिंग समथिंग. यू आर मिसिंग समथिंग, राइट? लेट मी टेल यू समथिंग. अभी थोड़ी देर पहले मैंने क्या कहा था, राइट? एंड let's stop here, right? So I am using actually this dashed curve because I am not interested in it. So only half of the journey. यहाँ पे vi क्या है? vi y 0, right? Actually he is calling it v0, right? So let's use label 0 for this, label 1 for this, and label 2 for this. So this will be v1 y equals, ये 0 नहीं है, सॉरी, ये 0 नहीं है. ये चूंकि थीटा है ना, if this is theta, this will be v naught cosine of, sorry, cosine नहीं, sine. Yeah, sine of theta. So if this is v naught and this is theta, this v0 y will be v naught sine theta. And what is v1 y? 0. And what is the average? This is the average, right? So v average y. ये बताइए इससे क्या वैल्यू आ रही है? Half of the, which is v naught sine theta. ये मैंने इसलिए बताया है कि आपको ये पता चल जाए कि जो एवरेज वेलोसिटी है, इट विल डिपेंड ऑन द इनिशियल स्पीड एंड द एंगल. ठीक है, और वहां पे क्या सेम है? सही, स्पीड सेम है, स्पीड दोनों का सेम है. सो इसका मतलब यह है कि द एवरेज वेलोसिटी बिटवीन दीज टू या विल डिपेंड ऑन थीटा. वी नॉट दोनों के लिए सेम है. सो कीप साइन थीटा इन योर माइंड. ठीक है, अब हम आ जाएंगे किस पे? टाइम पे. द टाइम इंटरवल नीडेड टू गो फ्रॉम दिस पॉइंट टू दिस पॉइंट, लेट्स कॉल इट डेल्टा टी. सो वो डेल्टा टी इसके लिए अलग होगा, इसके लिए अलग होगा, and that will be multiplied by 2, yeah, for this as well as for दिस। अब समझ आ गई बात? अब मुझे बताओ, हाउ डू आई कैलकुलेट डेल्टा टी? डेल्टा टी के लिए क्या है? I can use the equation which involves the acceleration and the velocity, right? Average velocity also um, so the height, you know, here the height is large and the height is small. So I can now use the equation for the height, which is delta y, yeah, the distance, and that will be equal to, no, I can use a simple equation, the average velocity times delta t. Or I can do something else. I can do this. This final velocity, how is acceleration related to this? Acceleration y, which you know is g, is minus g. Acceleration, you know, is delta v by delta t. And what is this delta v? v1y minus yeah, but I don't need v1. I don't want v1y is 0, right? v1y minus v0y, और इसमें क्या नोन है? ये 0 है, so it's minus v0, yeah, by delta t. Is this clear? Yeah? Does this make sense? Acceleration is simply the change in velocity divided by change in time. So this I know is 0. Actually, this was not needed, the average thing. This was not needed, right? So now I can bring this delta t here, and I can bring that g here. The minus and the minus will cancel out, right? So I'll get what? Divided by g. So actually this thing was not needed. Now think about this equation. And remember, this is half the time. This is not the full time. I'm only analyzing the problem from this point to. So the time of half the journey is v naught sin theta divided by g. अब यहां पे आपने सिर्फ ये देखना है कि कौन सी चीज मैटर कर रही है. g कांस्टेंट है दोनों के लिए, v नॉट दोनों के लिए सेम है ना, तो theta will be the determining factor. Theta will tell me which delta t is large. अब आप बताएं किसके लिए लार्ज होगा? उसके लिए लार्ज हो जाएगा, ठीक है? सो दिस विल हिट इट अर्लियर. नहीं, वो तो हमारा वो जी उधर नहीं है ना. एनी एनालिसिस अलोंग द एक्स एक्सिस विल बी मिसलीडिंग. समझ आ रही? ठीक है, उधर डिस्टेंस ज्यादा है, तो टाइम भी ज्यादा है, तो यू हैव टू थिंग्स गोइंग ऑन. आपने इक्वेशन वो यूज करनी है जिसमें सिर्फ एक चीज चेंज हो रही हो. यहां पे ट्रिक समझें, दोनों में एक चीज का फर्क है, वो क्या है? थीटा का है. व्हाई इज दिस रीजनिंग डेंजरस? बिकॉज आप ये कह रहे हैं कि ये डिस्टेंस ज्यादा है तो इसके लिए टाइम भी ज्यादा लगेगा, ये डिस्टेंस कम है तो टाइम भी कम लगेगा. दिस इज अ क्वालिटेटिव रीजनिंग. यू डोंट हैव एनी इक्वेशन. वर्टिकल में वी नो द इक्वेशन and we know that there is only one factor which is different, and that factor is the theta. Theta is the reason why this will take longer, and that theta is the reason why this will take shorter. So to be able to answer these questions, you need to combine math with your reasoning. अगर आप मैथ के बगैर रीजनिंग करेंगे तो आप क्या करेंगे? ये तो लॉन्ग डिस्टेंस है और ये शॉर्ट है, so this should take longer. So here actually there are so many things going on which you cannot distill. So when you have more than two factors, अब इसमें देखना, इसमें दो फैक्टर्स क्यों आ रहे हैं? इसका डिस्टेंस ज्यादा है, उसका डिस्टेंस कम है. अब देखो ना, इसका हॉरिजॉन्टल कंपोनेंट चेक करें, वहां पे कोसाइन थीटा होगा, ठीक है, कोसाइन थीटा, और इसका भी कोसाइन थीटा होगा. but the distance is also. Next question, ये देखें आप. This time different speeds.
Is I think one will be one will probably it's the same amount of height.
अब यहां पे आपको इक्वेशन हाइट के लिए चाहिए, ठीक है, एंड यू हैव टू नो कि हाइट और टाइम का, या यहां पे भी टाइम आपको मैटर कर रहा है. सो व्हाई इज दिस इक्वेशन नॉट इनफ फॉर दिस प्रॉब्लम? क्योंकि वी नॉट भी डिफरेंट है और थीटा भी डिफरेंट है. वी नॉट भी डिफरेंट है और थीटा भी डिफरेंट है, ठीक है. तो अब यहां पे या वी नॉट इज डिफरेंट, थीटा इज डिफरेंट. सो आपने क्या करना है, आपने हाइट को देखना है कि यू नीड टू हैव एन इक्वेशन फॉर द हाइट. और हाइट के लिए नाउ आई विल यूज दिस इक्वेशन. आई वाज नॉट नीडिंग दिस इक्वेशन अर्लियर. तो व्हाट विल बी द इक्वेशन फॉर द हाइट? एवरेज वेलोसिटी times delta t. You know, distance is always average speed times delta t. Delta t इधर से आ रहा है, तो let's multiply this. So आपके पास सिर्फ क्या आ जाएगा कि v नॉट sin theta divided by g times एवरेज क्या है? एवरेज ये है ना. सो दिस विल बी स्क्वायर. देखो ना, डेल्टा टी में वो वी नॉट साइन थीटा आ रहा है और वी एवरेज में भी वी नॉट साइन थीटा आ रहा है. तो वी नॉट साइन थीटा स्क्वायर्ड और 2g यहां पे क्या आ जाएगा? 2g. दिस इज नाउ योर फॉर्मूला फॉर द डिस्टेंस, फॉर द वर्टिकल डिस्टेंस. अब वर्टिकल डिस्टेंस दोनों का सेम क्या है? वर्टिकल डिस्टेंस दोनों का सेम है ना.
Same, man.
जो वर्टिकल डिस्टेंस सेम है, इसका मतलब टाइम भी सेम है. सो दे विल हिट एट द सेम टाइम. तो अब इस दोनों से हमने क्या सीखा है कि जो चीज मैटर कर रही है वो वर्टिकल डिस्टेंस है. और अगेन इसकी क्वालिटेटिव रीजन बताता हूं. हॉरिजॉन्टल यहां पे क्यों नहीं मैटर कर रहा? क्योंकि वहां तो एक्सेलरेशन जीरो है. तो जो चेंज आ रहा है वो देखो ना, कोकोनट वाले में भी ये आ रहा था. तीनों में एक ही फैक्टर आ रहा है, ग्रेविटी वर्टिकली है. हॉरिजॉन्टल में कोई, हॉरिजॉन्टल में आपका ए एक्स क्या है? कोकोनट वाले प्रॉब्लम में भी और इन दोनों में भी. सो जहां पे एक्सेलरेशन जीरो है वहां पे कोई भी रीजनिंग करने की जरूरत नहीं होती. सारी रीजनिंग कहां पे होती है? वर्टिकल, बिकॉज दैट इज वेयर द एक्सेलरेशन इज. सो इट इज द एक्सेलरेशन व्हिच विल डिटरमिन कि हाइट कितनी होगी. ये हाइट क्योंकि दोनों केस में सेम है, सो एक्सेलरेशन का जो इम्पैक्ट है वो दोनों पे सेम है.
सर जो फिर स्पीड होगी कांस्टेंट होगी,
नहीं, स्पीड तो चेंज हो रही है ना.
अगर एक्सेलरेशन जीरो तो स्पीड कांस्टेंट नहीं होगी एक्स.
नहीं तो वो तो हम ऑलरेडी वी नो दैट. या एक्सेलरेशन तीनों प्रॉब्लम में जो वेलोसिटी है हॉरिजॉन्टल वो चेंज नहीं हो रही. वो मैंने बता दिया था कि एक्स इज जीरो. सो व्हेन एक्स इज जीरो यू विल बी यूजिंग वी नॉट कोसाइन थीटा थ्रू आउट द प्रॉब्लम. Okay, I need actually, this is the problem here is that I want to solve one question and that question is not in the slide, so I have to move to the textbook for that. ठीक है. इन सारे प्रॉब्लम्स में जो चीज मैटर कर रही है वो वर्टिकल है. ठीक है, ये नोट कर ले बस. So now I know. Okay, I think this is the problem. ये चूंकि स्लाइड में नहीं है तो मैं इसलिए इसके लिए बुक खोल रहा हूं. ठीक है. या plotting a spacecraft trajectory. ठीक है. 4.3. Now the reason I want to discuss this problem is not because you don't know how to solve these equations, because now you know very well how to use these equations. कौन सा किस में डेल्टा टी आ रहा है, किस में नहीं आ रहा, so on and so forth. But I want to pay attention to another thing, which is ये वाला है या, बट आई थिंक दिस इज नो, ये इसमें वो जो चीज मैं बताना चाहता हूँ वो ये इसमें नहीं है, इससे पहले है वो, सॉरी, हाँ ये है, ठीक है, सॉरी. So this is the thing which is missing from these slides. Okay. Pay attention to the statement, right? अभी तक मैं आपको क्या बताया था कि जो भी सिंबल आप यूज करते हैं, T या V या X या R, तो उसमें फिजिकल क्वांटिटीज है, दे विल हैव यूनिट्स, राइट? इस एग्जांपल से आपको एक और हिंट मिलता है कि इफ यू वांट यू कैन, although we will not always be doing this, and the author is very careful not to repeat this thing in the following examples, but here he's trying something which you can do to simplify your calculation. He in this example wants to use these symbols without units. और ये ऐसे ही कि आपको एक दफा मैंने बताया था कि what is your height in meters. So if I say let's use h for the height in meters, तो फिर मैं h की जब वैल्यू लिखूंगा तो मैं उसमें साथ मीटर दोबारा नहीं लिखूंगा. ये बात समझ आ गई? तो यहां पे देखें कि he is giving you an equation for the position which has the x component and the y component, and pay attention to this component, 6.0 t minus 0.10 t squared. If you tell me that t will have units of, let's say, seconds or whatever, this 6.0 has no units. So when you multiply the two, you will get seconds, and here it's position, so it's wrong, right? And same is the case here, t squared. How can you have 1 second here and second squared there? So इसका मसला इसने कहाँ सॉल्व किया है? यहाँ पे देखो. Can you read that? T is in seconds. So t, the symbol t here is just a number, no units. So ना इसकी यूनिट्स है, ना इसकी यूनिट्स है, ना इसकी यूनिट्स है, ना इसकी यूनिट्स है. अब इसका मतलब क्या है कि जो टोटल क्वांटिटी हमारे पास एंड में आ रही है उसकी भी यूनिट्स नहीं है. तो R क्या है? R भी पोजीशन नहीं है, बल्कि R is in meters. अब समझ आ गया आपको? So you have a problem where the symbols carry no units. The units are in the language, not in the math. इसने सिर्फ ये एक यहां पे इसने गन मचाया हुआ, बताया वो क्या किधर है, इसी स्टेटमेंट में. And it is the reason why I reworked these examples in some document which I uploaded. Can you see the problem with this last part? What are the car's speed and direction? अब यहाँ पे you cannot use the same symbol with two meanings in the same question. That's not allowed. तो या ये गलत है या ये गलत है. तो मैंने क्या किया हुआ, मैंने इसमें से निकाल दिया है. It's t equals 120. I changed the question because that's the only way to make sense of this. So it must be a typing mistake. ये बात समझ आ गई? और बाकी इसके बाद आप ये कर ले जितने भी है. So आपकी जितनी भी कैलकुलेशन है उसमें कहीं पे भी कोई भी यूनिट नहीं होगा. और you can even change the question here. The car speed. What are the car speed? यहाँ पे आप लिख सकते हैं in meters per second. ताकि उसके लिए जब आप सिंबल v यूज करेंगे उसका भी यूनिट कोई ना हो. ठीक है? So I would highly recommend to read this solution and read the solution I uploaded, and then pay attention to how I actually fix some of the language. Yes. अब आप देखें इस let's say you calculate the answer. ठीक है? मैं बल्कि आंसर बता रहा हूं because the purpose is not to calculate. अच्छा, और इस प्रॉब्लम में वो, हाँ, इस प्रॉब्लम में I just want you to अब देखो ना यहाँ पे इसने किया हुआ है ना, तो ये ठीक नहीं है. आपको v ऐसे डिफाइन करना चाहिए कि उसका कोई यूनिट उसका ना होता है, इधर भी यूनिट ना हो, इधर भी ना हो. ठीक है? So let's ignore this, and now tell me the components are minus 18 and minus 33, and let's say you want to calculate the angle. तो ये कौन सा क्वाड्रेंट होगा? minus 18 minus 33. ये थर्ड होगा. तो जब थर्ड होगा तो आपको थीटा कैसे डिफाइन करना पड़ेगा? दिस इज द रीजन आई वांटेड टू डिस्कस दिस. ये x है, ये y है, ठीक है. अच्छा, यहां पे आपने कोऑर्डिनेट सिस्टम सेट किया हुआ है, ठीक है. x इज दिस वे, y इज दैट वे. तो अब व्हाट विल बी द बेस्ट वे टू लेबल योर थीटा? It has to be somewhere here. It needs to be acute, so you define it below the negative axis. If you define it above the x-axis, फिर आप इसका क्या करेंगे? और tangent inverse आपको help नहीं करने वाला. So this is exactly what he did. Both the components of the velocity vector are negative, so the direction of motion is to the left and down. Left and down. The angle below the negative axis. अब आप लोग ये नहीं पढ़ते, आप सिर्फ ये लिखते थीटा लिखा हुआ है. थीटा से पहले जो लिखा है वो पढ़ लिया करें, ठीक है. और यहाँ पे उसने फिर एब्सोल्यूट वैल्यू ली है क्योंकि यू डोंट वांट टू रिलाई ऑन दोज नेगेटिव साइंस. यू वांट टू सॉल्व द प्रॉब्लम योरसेल्फ. सो दिस कैलकुलेटर विल ओनली गिव मी एन एक्यूट एंगल, ठीक है. यस,
प्रोग्राम में क्वेश्चन में बिल्कुल भी यूनिट्स ना दिया गया हो तो we shouldn't write units in our answers.
yeah, but there is one thing is, that's a very good question, right? So let's say मैं इसमें ये तो ठीक कर दूं, but let's say I don't change this language, right? So remember, for my math, because all the symbols are not using units, so for doing math I will define my small v also without units, which means that it will be v, I will say v is n meter per second. But the question is not asking me v तो मेरा मसला है ना कि v को मैं कैसे डिफाइन करता हूं. उसने मुझसे क्या मांगा है? And speed, you know, will have units. तो जब मैं इसका फाइनल आंसर लिखूंगा तो ये तो मैं लिख दूंगा कि v की वैल्यू ये है और थीटा की वैल्यू ये है और ना इधर यूनिट होगा ना इधर यूनिट होगा. लेकिन जब मैं अपना फाइनल स्टेटमेंट दूंगा, so I will say that the speed of the car is this value and then I will say meter per second. वहां पे मुझे मीटर पर सेकंड लगाना पड़ेगा क्योंकि this math cannot change the meaning of speed. Speed always will have units.
During the equation, we shouldn't
Yeah.
but when we're giving the
When you are giving the answer, you will have to use the actual. So ये basically ये इसका वही है जो मैं बता रहा था कि you start from the real world, you go to the conceptual world, you go to the math world, but in the final answer you get back to the real world. तो यूनिट्स को आपने कहीं ना कहीं मेंशन करना है, ठीक. ओके, अब नेक्स्ट क्वेश्चन मैं इसलिए बता रहा हूं. अच्छा, मैं जो डॉक्यूमेंट मैंने बनाया वो यहां पे मैं नहीं खोलूंगा, आई वांट यू टू रीड इट योरसेल्फ, ठीक है. उसमें ये कोई इनकंसिस्टेंसी नहीं होगी. the thing which I want to address here now is this question, right? And this question he gets back to using units everywhere, right? तो अब देखो ना, ये just pay attention to this table. Everywhere you have units, right? ठीक है. But here is one problem which I solved in my document. He has violated one convention, and actually his own convention, because somehow he forgot that he has given that convention. Convention ये है कि जब आप subscript लिखते हैं तो t का क्या मतलब होगा? The coordinate time. But t0 will be just 1 point, yeah, time at point 0. So t1 will mean time at point 1. T2 will mean time at. So can you now tell me what's wrong with this? He is using t1 for that whole range of values, and that goes against the convention. So how will you replace this? You will replace this like this. For that you can only use t, because t is the coordinate. So this part will be replaced with this. You see? And now I can go even further. Let's call this t0, and let's call this t1. So I can even write t between t0 and T1, because now you know the meaning of T0. T0, T1 are fixed values. T is a coordinate. ये मैंने उधर फिक्स किया हुआ, ठीक है. टी हमेशा, मेरी बात सुनो, नहीं नहीं, यहाँ पे तो यूनिट्स इसके पास है, यूनिट्स का मसला नहीं है. मैं सिर्फ ये बता रहा हूँ. देखो ना, जो पिछला क्वेश्चन था उसमें मसला क्या था कि उसने मसला नहीं था. दैट इज अ वे ऑफ सॉल्विंग प्रॉब्लम्स. ये ऐसा ही है ना, जैसे मैं कहता हूँ कि लेट्स अस्यूम दैट दिस मार्कर इज L सेंटीमीटर. L सेंटीमीटर, तो इसका क्या मतलब है कि L क्या है? इट्स जस्ट नंबर. ये सेंटीमीटर मैंने अलग से दिया हुआ है. तो वो उस क्वेश्चन में वो तरीका था. यहां पे मसला वो नहीं है. यहां पे ही वांट्स टू यूज यूनिट्स एवरीवेयर, लेकिन यहां मसला ये है कि ही इज यूजिंग T1 एज ए कोऑर्डिनेट. T1 इज नेवर अ कोऑर्डिनेट. T विल बी द कोऑर्डिनेट. या क्योंकि द सबस्क्रिप्ट x1, x2, v1, v2 they are used for fixed values, and when you don't have subscripts, then you have coordinates. ओके, ये बाकी क्वेश्चंस आप जो है ना वो ये वाला एक क्वेश्चन मैंने सॉल्व किया हुआ है, जंपिंग फ्रॉग कॉन्टेस्ट. तो इसमें अच्छा, इसमें भी मैं सिर्फ ये बता रहा हूँ कि जो मैंने चेंज किया, बाकी डिटेल आप खुद देख ले. यूनिट्स इसमें सारे हैं, वो इशू नहीं है, ठीक है. इसमें सिर्फ ये चीज मैंने चेंज की हुई है कि जिस तरह प्रोजेक्टाइल वाले मोशन में आई टोल्ड यू दैट बिकॉज आई वांट टू यूज द एवरेज वेलोसिटी, और एवरेज क्या है? दिस वैल्यू प्लस दिस वैल्यू डिवाइडेड बाय 2, only allowed in constant acceleration. So what I have done, I have labeled this point as 0, this point as 1, and this point as 2. तो वो डायग्राम मैंने दोबारा ड्रॉ किया हुआ है. ये 0 और ये 1 इसको कह रहा है, तो यहाँ पे then you have no way to talk about that point. So I just relabeled it 0, 1, 2. और ये आपकी लेसन इसमें ये है कि you can do this relabeling as per your convenience. आप चाहें तो आप 0, 1, 2, 3 कर दें, if that helps you somehow. ठीक है. So ये कहीं नहीं लिखा हुआ. अच्छा, दूसरी बात, इस क्वेश्चन में दो पार्ट्स है. पहले वो जो फ्रॉग है वो स्ट्रेच करता है. तो जब वो स्ट्रेच करता है तो उस दौरान इट्स बेटर, क्योंकि उसने फ्लाइट भी लेनी है, तो ही इज डूइंग ऑल दैट एक्टिविटी एट सम एंगल. सो इट विल बी स्टूपिड टू यूज दिस एज योर एक्स एक्सिस, because he is doing every activity, all the activity there, so you can use that as your x-axis, so that you don't have to talk about the angle. समझ आ गई? There is no need to complicate the situation. But when you get to this point, now he is flying, so फिर ये x और ये y है. और एक और बात, ये इसको x0 कह रहा है, ये इसको x0 कह रहा है. So label 0 in this diagram means one thing. Label 0 in this diagram means, so it means that whenever you break your problem into simpler problems, you can use the same labels provided you specify it. तो ये अलग डायग्राम है, ये इसके अपने जो है ना वो पार्ट होगा, इसका अपना होगा, एंड देयर इज नो कंफ्यूजन. आप ये ना कहे कि अच्छा आपने इसको x1 कहा हुआ है और उधर भी x1, आई डोंट केयर, yeah, because these are different. So you can use the same symbols provided you explain it clearly. ठीक है? हाँ, कौन सा वाला, क्या मतलब? मैं कुछ और कह रहा हूं. What I am trying to tell you is that even here he is using x0 here and x0 here with different meanings. Why? Because this is one part of the problem, this is another problem, because these are two different, this has one coordinate system and this has, so you can use two sets of coordinate systems in the same problem. What I have done differently is not this. I also follow this procedure. I just introduced another label, so I'm calling this 1 and I'm calling this 2. There's no more difference. ठीक है? Okay, relative motion is very important. Quiz का टाइम हो गया है? Okay, ठीक है.